In this example, we are going to be working backwards because we've been given a trigonometric function and they would like us to express this function as a single trigonometric function. So that means we'll have to use our compound angle formulas to bring this back down into one single trig function. Well, that means we have to figure out which one are we looking at. Are we looking at sine of x plus y? Are we looking at sine x minus y? Or cos of x plus y? Or cos of x minus y? We got to figure out which one of these four we're looking at. Well, I know that both my cosine compound angle formulas both start with a cos x, cos y. Right? And then after that, it's either a minus or a plus. So I know it's not either one of those, because that would have been the cos x, cos y. So I know it's not either one of those. So it's not that, not that. That leaves me with two options for sine. And I know for my sine functions, whatever operation's happening inside matches what happens later on, where with cosine, the operation in here is actually opposite. So that's something that maybe you can help you remember or memorize these. So that means the operation in here matches the operation in between the two terms. Well, let's see what I got. I actually have a plus in here, so that means it's going to match that plus right there. So this is the trig function I'm using. Won't be that guy either. That means I'm going to be using sine x plus y because that compound angular formula goes something like this. Sine x cos y plus cos x sine y. So that's how this compound angle formula goes. So now all we have to figure out is what's the x and what's the y. Well, in my trig formula, I start off with my x. If those are my two x's, that matches with that and that right there, making my x be equal to pi. All right, well, what about my y? Well, this falls in the y spot here and here, and my formula there. That means my y is going to equal pi over 4. So let's bring both of these back into my single trigonometric function. So sine x and y, it's going to look like this. That means sine, my x is going to be pi, and my y is going to be pi over 4. So now I just have to clean this up, and that will be my single trigonometric function. Well, I'm adding this to a fraction, and I can't add those two together until they have a common denominator. So I'm going to have to rewrite this pi as something with a denominator of 4. Well, I can actually rewrite this as 4 pi over 4, because that would cancel out, leaving me back with pi again. So now that they have the same denominators, I can add these two things together. So 4 pi plus 1 more will actually give me 5 whole pi's over 4. And that is how you would have written that as a single trigonometric function.